Okay, so first step is we start a new Fluent. We go to our geometry, we change it to 2D, and then once that is done, enter so it's saved, open up our geometry, go to New Design Modeler, now we go to select our Z-plane, so we're looking at the right one. Units, make sure we're in inches, and then we're going to scroll out a little bit, go to Sketching, Line, and we're going to add 4 lines. So select the origin, horizontal, that point, horizontal, and we're just going to do this 4 times. Now we're going to go to Dimensions, General, and we're going to put 4 dimensions up for each of these lines. We're going to add more lines, this time the vertical ones. We're going to add 5 of these. 1, 2, 3, 4, 5. Perfect. Now we are going to go to our constraints, do the midpoint constraint so that each of these lines occurs on one of these points. Perfect. Now we are going to dimension again, add a dimension to each of these, and except for the last one, we're not going to dimension the height of that one. Perfect. Now our vertical ones are 22. Perfect. 22 here. 6 for this one. And last one is 6. Sweet. Now we are going to draw our exterior lines. Okay, need to make those coincident because I missed. Another line. Perfect. So now it's enclosed. We need our last dimension, which is an angle dimension between these two. I'll put it down here. And for this angle, let us do 180 minus 3. So it should be 177. Sweet. Now we are going to trim all the interior lines so that we are left with just the perimeter. Perfect. This should all be empty in here, nothing selected. And then now we're going to make a surface from the sketch using sketch 1 and generate. Perfect. Look around, it's a flat surface. Nice. And then we're going to do one more step, going back to sketching, looking in the Z direction. Dimensions, a horizontal dimension this time between the start and the end point. And we are going to convert that back into meters and take note of, that is H27, which is right here, 2.3622 meters. I already have an Excel sheet open, but when you make your Excel sheet, you can easily just Control C over that, and then just paste that number in here. You're going to save that for later. Total length. Nice. Now we go back, make sure it's fully generated, and back into this. Update the geometry, and we are going to double click mesh. Okay, now that we have our model in here, we're going to change the element size to 0.01, so it's extra tiny. And then we're going to go up to method and apply this geometry, and for our method we're going to go with triangles. Should be able to hit generate. It'll load, meshing done, click on the main mesh, and you should see a bunch of detailed triangles like this. Update, perfect, go back to the main one. And just to make sure we can update again, now we're going to go into our setup, double click, double precision, and we're going to use 2 cores. Let's start. That just makes it run a little faster. Now that loaded up pretty fast. Let's now just double check your fluid is air. Perfect. Right click energy and make sure it's on. Viscous, we're going to change this. We're going to K epsilon. We're going to do enhanced wall treatment and select both of the enhanced wall treatment options. Hit OK. Oh, almost forgot a step in the meshing. We need to go to edge selection and then hold Control and select all the upper and lower edges. Hit in and name these, I don't know, walls. Perfect. Now select the entry and do velocity inlet and the exit, hit in again, and we can do pressure outlet. Perfect. Update, back to this one, update just to be sure, and update setup. That'll take a little second. Okay, we need to update incoming zones, match zone names. Perfect. Okay, everything should be good now. Now let's enter our boundary conditions. Go to inlet, double click, and for the velocity magnitude, you need this equation. This is for the test section though, which is this area, the thinner area, and we want the velocity coming into the larger area. So what you're going to do is you're going to plug your fan speed hertz, for this one 20 hertz, into the equation. So it's 0.2489 times 20 hertz minus 0.3718. And then we're doing our A1 times V1 is equal to A2 times V2. And we're doing the area of the test section, which is 6 inches, divided by the area of the inlet, 22 inches, and we multiply that value by this to get our total velocity at the end that goes into the entrance. So we open this up, that value will go here. So I am just going to not double click, single click, Control V or Control C, go into here, then Control V, and that puts us the inlet velocity. Apply, close, and that should be the only number that we have to change. After that, just go to initialization, double click, initialize, ignore that, run calculation. Oh, yeah, calculate. Perfect. Nice, everything is displayed. Let's go to contours, and we're gonna just get everything in one contour. Let's start with a velocity. Let's do velocity magnitude, save and display. Wonderful. Now if we change that, next one, dynamic pressure, right here, double click again, and then we can go to total pressure. Yes. And after that, we're going to go to our XY plot, but we need a center line to run this XY plot off of. So we're going to add it, right click surfaces, new line, and that number that I saved earlier, the total length, I can just copy that, Control C, go back into this, and since it's the center line, we can start on x0, y stays 0, and we just give it the endpoint, create, and it should create a line from here all the way to here. Just to make sure, we can go to our contours and select only line 6, And yeah, we can do, let's do dynamic pressure. Save and display. You can see right there the line is up. And if we want to, we can do the wall surface, and that shows us, yep, it is centered. Perfect. Now we are going to go to our XY plots. We're going to do them over line 6, which is our center line. And we can start with velocity and select, save and plot. Boom, we get our velocity. If we do pressure, we can do our static pressure, dynamic, and total. Let's go to dynamic. Perfect. I'll show you total at the end. Yep, save and plot. Now you can just look at them to check, but the real thing that you need to do is you need to go right to file. So you're going to select each of these ones, and we can start with like velocity, and you're going to go right, and then you're going to type a name that you want to into the file. I would do 20 hertz velocity magnitude, boom, and then you would hit OK, and it would save. I'm not going to because I already have one saved for this. And once you have that, you're going to do it for your velocity magnitude, your static pressure, your dynamic pressure, and your total pressure. All of them you'll just check right to file and write. Once you have all those files saved, you should have 4 for your 60 hertz, 4 for 20, and 4 for 40. Those are all going to be just a plain text file. So you can double click it, open it in Notepad, and it will come up here. I've already highlighted the whole data, but you just want to start from the top and then just click drag the whole thing down. Going into your Excel file or sheet, since I'm poor, I divided it by color, so I have 60 hertz here, 40 hertz, and 20 hertz. You're going to do 4 sections of each. So you just copy, let's say you copied your velocity magnitude, you will click here and then Control V, and it will paste the entire thing all the way down. Mine came with like, how many? Like 462. And you're going to do that for every single test. It's going to be 12 tests. It's going to be a lot of data, but once you have it in, you're going to, right-click Insert and then add a graph. Setup of the graph can be a little confusing. Smooth line chart, and then data range. Since your data is not in a neat little area, you have to put it in custom data ranges. So for me, the X is the left one, Y is going to be right. So for your data range, you go with the right. So I would do D8 all the way through D462. And then you do the same with G and then H, because that's your Y data. Though I added in labels for 60 hertz, 40 hertz, and 20 hertz, so I actually start at D7, G7, and J7. Once you have those in, I'm going to cancel so I don't mess up my whole graph. Sweet, it didn't get messed up. Then you combine ranges horizontally. X-axis, you want to set that to be, you can just do one x-axis and do it your C from 8. Don't go from 7 because it will get this weird stuff in it. 8 all the way to the final value. And then it'll use that x-axis for all 3 of the datas. Let's double click again. And then the series, that's how you get these 3 lines in. So you'll select your, mine are labeled since I did all the way to the label, but if it's not, it will just select AK, AH, AE, and those will be your 3 series. I selected to use the row 7 as the header, and then you can just customize, add your title, all the fonts and stuff. And once you do that, you're going to just copy and paste 3 more of them, and then you just change your data input ranges. So from these 3 to these 3, and then the next set of 3, the next set of 3, and then boom, you have 4 charts. Now you're going to screenshot. I just do Windows Shift S for the data of the actual contours. So if we look at one of our contours, let's do this one. You're just going to screenshot over this contour, and then I just put all 3 of mine, made sure to label them 20, 40, 60 hertz, and then I put the graph of them all together. For static pressure, dynamic pressure, total pressure, All three of these are good now. So yeah, that is all for the project 3. Should be everything. Oh yeah, almost forgot. The way that you change to the other versions. Oh, why are there so much? Oh no, what did I do? Okay, that goes here. So this is right now set for the 20 hertz. The way that you change for the 40 hertz and the 60 hertz is you're going to go into your boundary conditions, and the only thing that is changing is this inlet velocity. So the nice thing about having it in Excel with an equation already written out is you can just duplicate the equation right here, and then you just change the hertz value. So 40 hertz, 60 hertz, and then you end up with the final velocity on the inlet. So you just copy that, you paste the final velocity into here. So when you change the velocity, let me show that. Control C and then Control V, change the velocity. It won't automatically change it even if you run calculation. You need to double click and initialize again. It will not save your data from the last one, so make sure you've screenshotted and exported all your graphs. Then you can finally run calculation. Calculation complete, and then we can look at our contour. It's gonna look pretty much the same with slightly different shading. As you can see from the graphs, it just slightly shifts over for each one. Yep, and then you do that for the 20, the 40, and the 60 hertz. You just redo each contour, screenshot each of them, and then your X and Y plots, if you've done them all, they'll all be saved here just like the contours, so you can just open them up and re-export. That should be everything. For real this time.